Okay, we're going to compute this derivative using implicit differentiation. As you can see, it's a little bit complicated looking in that we have two things on the left-hand side that are connected with multiplication. So as we work this out, what I'm going to do is go ahead and set up, it's a product, we're going to use the product rule. So I'm going to use f times g, kind of visualizing f as being that x squared function, and g as being our tangent of y function. So on the left-hand side, let's go ahead and set it up as f prime times g plus f times g prime, and kind of work our way through filling in as we go. So the x squared, as we take its derivative, it's going to be 2x to the first power using the power rule. And because our variable there is x, we don't really need a dx over dx. All right, so next we go ahead and bring along our g function, which is tangent of y. Didn't take its derivative, so we don't have to worry about a dy over dx. Plus, simply copy down our x squared, our f function, and multiply it by the derivative of tangent of y. So in this case, that's going to be secant squared of y. But we also have to be a little bit careful that our variable was y as we were taking the derivative here. So we want to either indicate it, we're taking the derivative with respect to x of a y with a dy dx, or you can use y prime in that spot instead. Now over on the right-hand side, as we look at the derivative of 50, 50 is a nice constant. Its derivative is going to be 0. All right, all that remains is really doing a little bit of solving down, isolating that dy over dx. So the first thing I'm going to do is move that 2x multiplied by tangent of y to the other side by subtracting it. All right, that'll eliminate it from the left-hand side. We're going to be left with x squared times secant squared of y with that dy dx. And on the right-hand side, sure enough, it's just negative 2x tangent of y. And to get the dy dx on one side all by itself, you should note that it's connected with everything else on the left-hand side with a multiplication. So all we have to really do is divide both sides by x squared and by secant squared y, and we'll have our dy dx on the left-hand side all by itself. Okay, from here, let's go ahead and mention we can simplify down the right-hand side a little bit more. And this is the same thing as y prime. On the right-hand side, we're still going to have the negative and the 2, but our x's do a little bit of simplifying, right? We have 1 in the numerator. That'll eliminate 1 from the denominator as you simplify this down. So we still have the tangent of y in the numerator. We still have 1 copy of x in the denominator, and we have the secant squared of y in the denominator. Can't really simplify any more than that, so we're done. That's our derivative using implicit differentiation. Hope this helps out. Good luck.